Good morning, I am Judith Manu Gracelyn. Today we are going to discuss about chemical bonding and biocoordination compounds. Chemical bonding. A chemical bond is a lasting attraction between atoms or ions that enables the formation of molecules, crystals, and other structures. The bond may result from the electrostatic force between oppositely charged ions and in ionic bonds or through the sharing of electrons as in covalent bonds. The strength of chemical bonds varies considerably. There are strong bonds or primary bonds such as covalent, ionic, and metallic bonds, and weak bonds or secondary bonds such as dipole-dipole interaction, the London dispersion force, and hydrogen bonding. Does a chemical bond occur? How does a chemical bond occur? Every atom is composed of a core with positively charged protons and neutral neutrons, and it is surrounded by an outer layer called the electron cloud, which has a negative charge. Opposite charges attract both within the same atom and between atoms. The attraction forms chemical bonds between different elements. Atoms round out their electric charges by electron exchanges. They can give up, accept, or share these particles or achieve a stable electronic configuration, meaning a lower energy consumption. Characteristics of chemical bond. They hold atoms together inside the chemical molecules. The strength of a chemical bond is determined by the difference in electronegativity. Generally, the numbers of electrons are even. Covalent bonds can exist as a gas, solid, and a liquid. Some covalent bonds are soluble in water, while others are in organic solvents. Acid covalent bonds conduct electricity in the presence of an aqueous solution. Ionic bonds have high melting and boiling points. Metal bonds are good conductors of heat and electricity. They are typically in a solid state and they are highly malleable. Types of chemical bonds. There are covalent bonds, ionic bonds, and metallic bonds. Covalent bonds occurs when non-metallic atoms share electrons. Ionic bonds, this occurs when metallic and non-metallic atoms bond and then electronic charges is given from one to the other. Metallic, these are formed between atoms of metals whose atomic nuclei gather and are surrounded by their electrons like a cloud. Lewis theory. American chemical physicist Gilbert Lewis divided the octet rule in 1917. It explains how atoms of different chemical elements combine to form bonds. This theory proposes that the ions of elements on the periodic table fill their last energy levels with 8 electrons. This way, the molecules achieve stability at the level of their electronic structure. Thus, elements with high electronegative charges gain electrons until reaches the octet, while those with low electronegativity usually lose to achieve the same goal. Lewis' theory of chemical bonding. An atom can be viewed as a positively charged kernel and the outer shell. The outer shell can accommodate a maximum of 8 electrons only. The 8 electrons present in the outer shell occupy the corners of a cube which surround the kernel. The atoms have an octet configuration, 8 electrons in the outermost shell, thus symbolizing a stable configuration. Causal's theory of chemical bonding. Noble gases separate the highly electronegative halogens and the highly electropositive alkali metals. Halogens can form negatively charged ions by gaining an electron, whereas alkali metals can form positively charged ions by losing an electron. These negatively charged ions and positively charged ions have a noble gas configuration, that is 8 electrons in the outermost shell. The electron configuration of noble gas is given by Ns2 and P6. Biocoordination compounds. Coordination compounds plays an important role in many biological processes in plants and animals. Names and functions like hemoglobin, that is a transport and storage of oxygen, chlorophyll, that is photosynthesis, and ferredoxins, rubridoxins, that is an electron transfer. Hemoglobin in the red blood cells carries oxygen from the lungs to the tissues. It delivers the oxygen molecules to myoglobin in the tissues. When the oxygen has been released for cell respiration, hemoglobin loses the bright red color. Next, the chlorophyll. Chlorophyll is a magnesium porphyrin complex. The magnesium is at the center of the modified porphyrin ring section. The oxidation state of the magnesium is +2, Mg+2. The modified porphyrin acts as the ligand. There are several kinds of chlorophyll that vary slightly in their molecular structure. In plants, chlorophyll A is the pigment directly responsible for the transmission of light energy to chemical energy. Thank you.